M.S. Ramaiah University of Applied Sciences.
LCR resonant circuits. Hello students, let us discuss the study of frequency response curve of an LCR circuit and determination of the resonant frequency, bandwidth and the quality factor. First, let me discuss about the LCR series circuit. LCR series circuit consists of an inductor, capacitor and resistor connected in series along with AC source. The frequency response curve of an LCR series circuit is as shown in diagram. Maximum current in the circuit corresponds to a frequency known as resonant frequency. LCR parallel circuit consists of an inductor, capacitor and resistor connected in parallel along with AC source. The frequency response curve of an LCR parallel circuit is as shown in diagram. Minimum current in the circuit corresponds to a frequency known as resonant frequency. A LCR circuit is said to be in resonance when the capacitive reactance XC is equal to inductive reactance XL. Resonant frequency can be calculated from the value of capacitance and inductance using the formula as shown. Sharpness of resonance of a circuit is the measure of the ability of the circuit to differentiate different frequencies of nearly equal magnitudes, and it is a dimensionless quantity. Quality factor depends upon resistance, capacitance and inductance of the circuit.
Hello students, in this experiment let us study the frequency response of series and parallel LCR circuits and determination of resonant frequency and quality factor. The required apparatus are connecting wires, function generator, LCR series and parallel resonance kit. The function generator has fine and coarse frequency knob, where fine knobs can vary from 1 to 10 and coarse knob can vary from 1 to 20 kilo, and function knob, where in this experiment we should keep the function for sine wave, and there are two knobs called coarse and fine amplitude knobs, where coarse knob should be there in the position of 1 and finer knob should be at right side extreme end. These two are the output terminals. It will be connected to LCR series and parallel resonance kit. LCR series and parallel resonance kit as milliammeter, where we can determine the current in milliamps. Resistors R1, R2, R3 and a capacitor C1, C2, C3 and inductance L3, L2, L1. Here the R1, R2, R3 resistors value can be determined by knowing the color codes, and the value of C1 and C2, C3 are written here. The values of L3, L2, L1 are written here. In this experiment we are going to use R1, C1, L1 combinations only. Let us start the connection for LCR series circuit. Connect a wire from output terminal to the first knob of the milliammeter. Then connect a wire from other terminal of the milliammeter to an inductance of L1. Here red knob is the common terminal for all the inductance L1, L2, L3. Now from this red common terminal of inductance connect to C1 terminal. From other knob of the C1 terminal connect to R1 terminal. from the other terminal of the R1 to other terminal of the function generator. Let us start the experiment. First, switch on the mains. Then switch on the mains of function generator and mains of resonance kit. Now let's turn the coarse frequency knob to 100 position and finer knob to 1 position. Now the frequency is 1 into 100, that is 100 Hertz. Corresponding milliammeter reading is noted down. Now turn the finer knob to 2 position, that is 200 Hertz. For that, corresponding milliammeter readings are noted down. Similarly, current readings are noted down for 300, 400, 500, 600, 700, 800 and 900 Hertz. Now turn the coarse knob to the 1K position and bring back the finer knob to the 1 position, that is 1 into 1K is 1 kilohertz, and note down the corresponding current readings. Now turn the finer knob to 1.5 position, that is between 2 and 1, that is 1.5 kilohertz. Note down the corresponding current reading. Similarly, turn the knob to 2, 2.5, 3, 3.5, like that up to 8 kilohertz, and note down the corresponding current readings. From the tabulated values, plot the graph of current versus frequency. From this, measure the resonance frequency corresponding to maximum current, which is the resonant frequency for series LCR circuit. Now let us start the connection for parallel LCR circuit. Now connect a wire from output to one of the terminal of milliammeter. Then take another wire and connect from other terminal of the milliammeter to one of the terminal of R1, and connect a wire from the same terminal of the R1 to one of the terminal of C1. Then take a wire and connect from the same terminal of C1 to the common terminal of the inductance. Then take one more wire and connect from other terminal of the R1 to another terminal of the C1, and take one more wire and connect that from the same terminal of the C1 to another terminal of L1. Then take one more wire and connect from the L1 to other terminal of the output. Let us start the experiment. Switch on the mains of function generator and resonance kit. Note down the current reading for different values of frequency which we have set for series LCR circuit. From the tabulated value, plot the graph of current versus frequency. From this, measure the value of resonance frequency, which is corresponds to minimum current, which gives the resonance frequency for parallel LCR circuit.
At MSR UAS, we spark your imagination unlike any other.